This is lesson 2.6, perimeters and areas of similar figures. The essential question here is how do changes in the dimension of similar geometric figures affect the perimeters and the areas of the figures. So first off, our key idea here is that perimeters of similar figures. When two figures are similar, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So in other words, if we're looking here, we're going to be finding in example 1, finding the ratio of perimeters. So we're going to find the ratio of the red to the blue of the perimeters of this triangle. So you're going to find the perimeter of the red over the perimeter of the blue. And that's going to be equal to 4 over 6, which is 2/3. See, I got my 4 and my 6 right here, because of the corresponding sides. So the ratio of the perimeters is also 2/3. So let's try this here on number 2. Find the ratio of the areas. So we're going to find the ratio of the red to blue. So when we're finding the area of the, comparing them of the similar figures, you're going to take the area of the red triangle over the area of the blue triangle. And that is actually going to equal the ratio of the sides squared. So the sides, the red is 6, the blue is 10. So the ratio of 6/10 squared. Well, I can simplify 6/10 to 3/5 here, and then square it. Remember, when we square it, 3 squared over 5 squared, which is 9 over 25. So the ratio of the areas is 9 to 25. Now, how am I going to use this here, using proportions here to find the perimeter and areas? So a swimming pool is similar in shape to a volleyball court. Find the perimeter and the area of the pool. So the rectangular pool and the courts are similar. So we're going to use the ratio of the corresponding side lengths to write the write and solve proportions to find the perimeter and area of the pool. So remember, the perimeter is going to be the perimeter of the court over the perimeter of the pool is going to be equal to the width of the court over the width of the pool. So we've got here that perimeter of the court and over the perimeter of the pool is equal to the width of the court, which is 10 yards, over 18, which these are going to simplify to 5 over 9. So the ratio of the perimeter would be 5 to 9. But we know that the perimeter of the court is 60, so to find the perimeter of the pool, I can plug that number in. And I could have 60 over the perimeter of the pool is equal to the 10 over 18. When you cross multiply, you get 10p equal to 1080. Divide by 10 and you get p equal to 108. So now how about the area? The area of the court, which we don't know, so the area of the court to the area of the pool, which is given as 200 yards, is equal to the width of the court, which is 18, over, I'm sorry, not 18. The width of the court, remember to keep them the same, is 10 over 18 squared. So we're going to get rid of that squaring. Oh, I messed up here too. This actually is upside down. The area of the court is 200, and the unknown is A. So, we're going to get rid of the squared sign, which equals 100 over 324. Cross multiply, so you get 100A equal to 64,800. Divide by 100 to get A by itself, and I get the area of the court is 648 yards squared. So the perimeter of the pool is 108 yards, and the area is 640 square yards. Go ahead and finish up your notes, and then bring them up to me to check off, and then get started on Clever.